Hello everyone, and welcome to another episode of BMED 202. In this episode, you will be given an introduction to beams and how they react to different forces. We will also briefly look at shear forces and bending moments. Stay tuned. Okay, so what is a beam? A beam is a horizontal structural member that bears loads, and these loads can be vertical loads as well as shear force as well as bending moments. And I'll explain what shear force and bending moments are in a bit. Now, if you look at this diagram, you'll see this is the beam and it's horizontal, while these are columns which are supporting the beams. Now, beams have to be supported at either one end or at both ends, or at least different points if it's not the end. Let's look into the different types of beams that exist. Now, beams are classified based on how they are supported and the type of supports that they are supported by. Now, there are 4 types of beams that I'm going to look at today. There are more, but these are the 4 that I'm going to look at. The first type is a simply supported beam. And a simply supported beam is a beam that consists of a pinned support at one end and a roller support at the other end. Now, as you can see, this is a pinned support, this is a roller support. I'll explain what those are in a few. The next beam is a cantilever beam, and this consists of only one support at one end. And this support is a fixed support. I'll explain what that is in a bit as well. Then you have an overhanging beam, which consists of 2 roller supports as well as ends extending beyond the supports. Now, it can only be one end extending, any one end, or it can be both ends extending. And the final beam that we'll look at today is the continuous beam, which consists of 3 or more supports along the beam. Here you have 2 supports at the end. This is a pinned support, and you have 3 roller supports along the beam, one of which is at the other end. Now, you may be wondering, what are the different types of supports? Let us have a look on the different types of beam supports. Now, a pinned support is a type of support that allows for rotational movement while resisting horizontal movement and vertical movement. The roller support, on the other hand, allows for both rotational movement and horizontal movement. As you can see the diagram here, it's on a roller, so it's facilitating left to right movement, which is horizontal, and it's also supporting or facilitating rotational movement about the point of support. If you look, it is not facilitating vertical movement. However, it's resisting that vertical movement. So both the pinned support and the roller support facilitate rotational movement. Both of them resist vertical movement. However, the roller support facilitates horizontal movement, and the pinned support resists horizontal movement. If you look at the fixed support, however, it resists rotational movement, horizontal movement, or horizontal forces being applied, and it will also resist vertical forces being applied. So let's go back to this pinned support. If you're going to apply a force of 5 newtons, it will not resist that 5 newtons. So regardless of what X is, there will be no resistance. So if X is 10, the resistance will be 0 because there's no support at the other end to resist that force. And since this is a pinned support, it facilitates rotation, and the member or the beam will rotate. Right here, if you are going to apply, let's say, a force of 5 newtons to this end, there will be a resistance force of 5 newtons at the other end, given the fact that a pinned support rather, does not allow for horizontal movement, right? So unless the member, the beam fails, or unless the support fails, any amount of force that is applied here will be resisted here. If the force is applied here, it will be resisted here. If you look at the vertical forces that are applied to a pinned support, it will be the same as the horizontal. If you apply a downward force, an equal but opposite upward force will be applied, or will be the result, unless the beam or the support fails. If you look at the roller support, once a force is applied that seeks to put the body in rotation, there will be no resistance. So if x is 10, the resultant or reaction force will be naught because of the pivot, unless there's a force on the other end. Now, if you look at the horizontal forces that are applied, the same can be said. If you apply a force of 10 newtons, since it is on a roller, it will not resist and the body will move. However, if a vertical force is applied, since roller supports is not able to move vertically, it will resist. So if 10 newtons is applied here, there will be a resistance of 10 newtons. The fixed supports resist all types of movements, hence the name fixed support. So if you're trying to rotate this member, whatever force is applied, an equal and opposite force will be exhibited until or unless some part of the member fails. Likewise can be said for horizontal forces, they will be resisted, and vertical forces that will be resisted. So that's all you need to know about for the different types of supports for beams. Okay, if you look at these images, you will see on the right, bending is taking place, or on the left rather, and on the right, shearing is taking place. Now, this beam, as a result of this force, is undergoing bending, and the bending is causing or can cause failure. Now, this is the type of failure that this particular bending can cause. Over here now, you have shearing is taking place here. Once the member is not able to withstand the shear force that is being caused as a result of this force being applied, then the member will fail, right? And the shearing is taking place here because there's a force here and there's a force here, right? So shearing is taking place here because of the body's inability to resist or incapability to resist. Now let's look at how our body is responding while it is being bent. Now, when a body is being bent, depending on if it's sagging or hugging, compression and tension will take place at either the top of the member or the bottom of the member or the beam. Now, if it's sagging, compression will take place at the top as the members will seek to push together, or the particles, while tension will take place under the beam because the particles will seem to pull apart. Hugging, on the other hand, tension will take place at the top while compression will take place at the bottom. Now, the bending that is taking place as a result of sagging will be a positive bending moments, or will be positive bending moments, while for hugging, the bending moments will be negative. As we proceed in this series, or in further episodes, it will be further explained what bending moments are and what shear forces are. I hope you have learned or grasped the concept or concepts that were taught in this video. I hope that you share the content and like and subscribe. Have a good day.